up louder than me.
Please be quiet.
I will. All right.
Sorry.
We will be doing number 20 now. And Lindsay's going to help me. Lindsay, looks like we have to figure out how many blueberry pies, chocolate, and cheesecake.
Yeah.
So I think I'm going to use B for blueberry and C for chocolate. No, I better use T for trifle and C for cherry cheesecake. So just to repeat that, this is how many blueberries. This is how many chocolate trifles, and how many cherry cheesecakes. Now will you read me some hints and we'll try to make equations or formulas out of those.
Okay. There's 400 guests.
They each get one piece of pie?
Let's see. Yeah, they can choose one of 3 options for dessert. The chef preparing the desserts must spend 5 minutes on each pie, 8 minutes on each trifle, and 12 minutes on each cheesecake.
All right, so I think this has to equal 400 then, because you need a piece of pie for every person, don't you?
Yeah.
All right, and then you told me about the time, how much for each blueberry?
5 minutes.
So if you spend 5 minutes on every blueberry and
8 minutes on each trifle,
8 on the chocolate trifle,
and 12 on cheesecake.
does it tell you how much total time?
Yeah, exactly 45 hours.
Whoa, this is minutes though, so I'm gonna do like a 45 times 60 there, right there like that.
Let's see. The total cost of all the desserts is $1,170.
Like that.
Yep. And
Well,
then
how much are they a piece?
the blueberry is $3 a piece.
3 for every blueberry.
The trifle is $2.50.
Can I say 2.5 then? Yes, I can.
And then the cheesecake is $4.
That means they're the best. All right, I think I've got them nicely in columns here for you, Lindsay. Put a 1 right there, of course. And whatever that is over there. I think if you just put this into your matrix or into your calculator, that'll be good enough to solve it up. And B, the first letter you get will be B, and so forth. Jordan had a request.
9 or 10 for both. 9, please.
9.
9?
Yes.
Okay.
Now doing what?
And 10 also?
You can't ask 2 requests at once, it confuses me.
Well, she says 9 and I'll say 10. So it's 2.
We'll try to do 9 and 10.
Yeah.
We'll have to go kind of
Number
fast.
1.
Start telling me about these gigabytes. First of all, Jordan, it looks like there's movies and talk shows and sitcoms.
Yep.
Well, let's call them sitcoms, movies, and talk shows, all right? Do you know the total number of those? Is that in there?
9.
9 total programs were recorded?
Yep.
I think that 9 should be right here. And that's not considering, so now this just stands for how many sitcoms, how many movies, and how many talk shows.
Okay.
All right, another hint, like for,
The amount of gigabytes?
yeah, let's go gigabytes. What's the total gigabytes?
5.4.
That should go here. And then we should know the gigabytes for each sitcom.
So, a sitcom is 0.3.
So that looks like this then, 0.3 for every sitcom,
A talk show is 0.6.
0.6 for every talk show.
And a movie is 1.2.
So there's 2 hints for you. There must be one more thing in there because we have 3 missing variables.
Yeah. Probably the amount of time each one is.
Time?
Yeah. Well, cause it says like 1 hour talk show uses 0.6 minutes.
All right, but does it give you a total time?
Two,
It doesn't, does it?
no.
So that's not gonna be helpful.
Okay.
Any other little thing in there?
She downloaded 2 more sitcoms and movies.
That's helpful.
Teachers, sorry for the interruption. Mr. Van and Vandepol asked me to announce that they've updated the schedule. We are going to end second period at 10:30 and start fifth period at 10:35. So second period will end in just a little over half an hour at 10:30, and fifth will start at 10:35 and run for its normal course. Thank you.
Am I on the screen here?
You are.
All right. Jordan, please read that third hint again. I don't think the time is helpful because we don't have a total time, but you had another thing there.
Okay, it says.
Slow, because I want to match your words, nice and loud and slow.
If she downloaded 2 more sitcoms and movies.
There's 2 more sitcoms than movies.
Yes.
So pick one of these. The movies is 2 more than the sitcoms, or the sitcom is 2 more than the movies. Which do you feel fits the hint?
Movies equals sitcoms plus 2.
So you're saying there's more movies?
No. No. There's 2 more sitcoms and movies.
So you would add 2 to the movies to match how many sitcoms?
Yes.
All right, be careful with that, everybody blows that. Now, if I was to take this and put it up in correct columns, the 2 is on the right, the M is on the right, so if you put it on the left, that would be -1 M. The S is already on the left, and then you'd have to have a 0 there. So, Jordan, I think you'll get everything correct. Now, if you would put that in your matrix.
Okay.
And then we have a request for number 10. The basketball that Caden got correct. Laura, you will help me a little bit?
Sure.
Laura does, there's 3 things to find. There's free throws, 2 pointers. Well, that didn't help. And let's go like this. And 3 pointers, all right? So that'll be our 3 variables. We don't know how many free throws, how many 2s, and how many 3s. What are some of the things we know?
That he scored 37 times.
When you figure out that, I mean, that's just flat how many buckets. That should go like there. That isn't even considering 2 for some of them and 3 for some of them, right? That's just 37 times scoring. All right, what else do we know?
He scored 70 points.
Or when we put down the 70 points, that's figuring 1 for these, plus 2 times every one of these, plus 3 times every one of these. So that's how that 70 would have been arrived at. It needs to be one more hint.
The sum of his 2 and 3-point shots equals twice the number of free throws minus 2.
The sum of his 2 and 3-point shots equals twice the number of free throws minus 2. So now we have to take this and get it rearranged into the same column plan. I think that -2 will still be over there. I think this 2F will be a -2F when it's over here. This is just 1 TW and 1 TH. So I think, Laura, you should go with 1, 1, 1, 37, 1, 2, 3, 70, -2, 1, 1, -2. Now I will segue right into the next lesson. Please turn to page 410. We're on 410. Calculators out. Need the calculators out. And to explain the lesson, I'm just going to do number 1 of the assignment for you. That's number 1 on page 410. Got your calculator ready?
So is our assignment 6-5-1-11?
Yes. And I'm doing the first one. Number 1. It has a 3x plus y as the objective function, and then 3 other functions that we're going to try to graph. So the first thing we're going to do is on our calculators, we're going to try to graph y less than or equal to 2x plus 1. Can you graph y equals 2x plus 1 on your calculator? I graphed y equals 2x plus 1, and I got a line that goes about like this. Then you want to graph the second one that says x plus 2y. X plus 2y is less than 12. Kind of have to rearrange that. You have x. Just for the record, that was a miss. So I just graphed 6 minus x. I figured it'd be the way to graph that equation. So I've graphed that in blue on the same graph.
Why is it 1? Just minus x, wouldn't it be 0.5?
Oh yeah, I did that. So, for the record, Luke caught an error. Nobody knows if I did it on purpose or not. All right, do you have a similar looking graph? Now I think it says on this also that y is between 1 and 3. So you could graph, if you wanted to, you could graph a y equals 3 and a y equals 1. Now I haven't talked yet about the less than and greater than symbol. Go up to your first one and take your calculator and arrow up, and then way to the left, and then I think if you hit enter different number of times, you can get a option that shades above or an option that shades below. We have to decide, since it's a greater than or less than, we have to decide whether we're going to shade above or below. So we'll just check a spot that's not on this line. Well, the easiest one to check is 0, 0. Wait, right there. 0, 0. 0, 0. If x is 0, y is 0. It's, look, 0, 0 works here. Since 0, 0 works, it should be on the shaded side. So we're going to shade under. So you should choose the option that shades under the line. Are you showing, Luke, how to do that?
Should I do that?
Can you?
Like that?
Nice. Luke has chosen that. We'll show that right here under the y equals button. Notice he chose the undershade for the first one, and it looks like he's picking it for the second one also. Let's check my blue line, or the 6 minus 0.5x. If y is less than 6 minus 0.5x, I'm talking about which side of this blue line for mine to shade. And it looks like if x is 0, you'll have, if you go, if we pick this point 0, 0, 0, 0, is 0 less than 6? Yep, so it should be on the shaded side. So this one, Luke is right. We're going to shade below the other graph line also. We also have to be between 1 and 3. So I think if you are below this one, below 3, and above 1, there's only one area that covers all of that, and I think it's like a little trapezoid shape right in here. Now sometimes if you shade too many areas on your little handheld graph, it's hard to see which area is shaded 4 times. You might want to churn 2 of them off and look at 2 at a time a little bit to see it. But you should arrive at the conclusion that this area right here is shaded 4 times, because it has to be less than this line, less than this line, it has to be above 1, below 3, only there is all that. The next step is to look at the corners of that little area. We want to find the corners. I'll label them. I've got corners at 1, 3. Six, 3, 10, 1, and 0, 1. Those are the corners of my, what I call my answer trapezoid. All the spots in that trapezoid fulfill all the restrictions. They meet all the restrictions. So the answer is really unlimited points in that trapezoid. Now the final question is, what is the maximum and minimum of the objective? The objective goes 3x plus y. That's the first thing they have down there. 3x plus y. if I go 3x plus y here, that's 3 times 3, I get 6. I'm just gonna put a 6 over by that one. 3x here, 18 plus y, 21. 3x plus y here is 31. 3x plus y here is just 1. So the max is over here. I'll just write that. Max at 10-1. Min at 0-1. These are the kind of solutions that are often used when there are several restrictions and several degrees of freedom in some problem, like you can decide how many of one object to make and how many of another object to make, but you have to stay under this limit. But you have to keep those guys busy, so you have to make at least so many of these. And because of supply, you can't do this, and there's going to be limits and freedoms, and it gives you an area within which you can work. Then you find your best profit or least cost sometimes. I'm going to do one more. I'm going to do number 11. That'll leave you to do in between there. May I erase this? Do you think you have that?
No. Okay, my graph is, can you come look at this,
We're looking at Jordan's graph.
What is wrong with this? Luke, stop. It's like it doesn't.